Alright, so for this proof, just like all the others, you gotta come up with a game plan. Now apparently last class we already came up with that. But when you start a proof, you need to take each given statement one at a time and think about and mark your diagram and say, okay, what are the implications of this given information? And mark up your diagram and then figure out a logical way to get to whatever your proof statement is or what you're trying to prove. In this case, that is that angle 1 and angle 2 are congruent. And so knowing your end goal is extremely important, but you have to know where you're going or what's your final destination to be able to get there. So first off, I'm going to take the given statement. So this first one, that segment PQ is congruent to segment PR. So what are the implications of that first given statement? What do I know because of that? Okay, so we know that angle PQR is congruent to angle PRQ. Now what justifies this statement that I just wrote? The base angle theorem. It's the same exact thing as the isosceles triangle theorem. If you know that two angles are congruent, then what else can you say about those two angles? Their measures are equal. What justifies the statement that I'm writing now, that the measure of angle PQR is equal to the measure of angle PRQ? Definition of congruent angles. That's what justifies that. Alright, so I think we've milked that first given for all that it's worth, so let's go to the next one. The fact that segment TQ is congruent to segment TR. So I'm going to mark that in my diagram. Notice how I'm putting 2 marks of congruency on these different segments, because we don't know if they're all congruent, so don't just start putting 1 mark of congruency everywhere. So sweet, we got this. What's the implications of this second given statement? What do we know now? Angle 3 is congruent to angle 4. So angle 3 is congruent to angle 4. What justifies the fact that angle 3 is congruent to angle 4? Same exact thing. The base angle theorem or the isosceles triangle theorem. The same exact thing. Awesome. So, from there we've used up all of our givens. We know that because of the first set of givens, these 2 large base angles are congruent. Therefore, their measures are equal. And then our second given statement, we use the same theorem, the base angle theorem, to say that this triangle's base angles are congruent. So that's all the given information. Somehow we now have to get down to proving that angle 1 is congruent to angle 2. And so if we just kind of take a step back and think about what's happening here, we know that these whole angles are congruent, the ones in red. We also know that these whole angles are being broken up into 2 parts. For this angle, angle 1 and angle 3, this one, angle 2 and angle 4. We also know that one of these corresponding parts that the whole is being broken up to, we know that they are congruent. So if the wholes are congruent and one of the parts are congruent, that forces the other part to be congruent as well, the same exact size and shape. So how do we go about doing that and showing that? We're going to have to use a lot of angle addition postulate and a lot of substitution. So let's get down to it. Like I said, because these wholes are congruent, we got to break them down into their parts. And so we got to represent these whole angles as a sum of their parts. So the measure, this first one, the measure of angle PQR, that is the measure of angle 1 plus the measure of angle 3. That equals the whole PQR. What justifies this statement here? Angle addition postulate. Part plus part equals whole. Whenever you use the angle addition postulate, it must only contain variables. You are not allowed to write an equation that, use an angle addition, part plus part equals whole, and also substitute something in. Like, maybe we knew the measure of angle 3 was 80 degrees. You're not allowed to write this equation and plug some value in at the same time. So that's 2 separate steps. This is angle addition postulate. If you want to plug something in later, you can by using substitution. So very different. So we need to now also represent the other angle as a sum of its parts. So that would be the measure of angle 2 plus the measure of angle 4 equals the measure of angle PRQ. So I'm taking these big base angles that are congruent, meaning their measures are equal. I'm taking them and broken them up into their parts using the angle addition postulate. Both of these statements in black ink is justified by the angle addition postulate. From there, we're just going to use a bunch of substitution because I can see that, well, because these measures are equal, because the holes are equal, I'm going to set these two expressions equal to one another. And so this is what I'm going to be doing. Instead of having the measure of angle PQR, I'm going to replace it with the sum of its parts. So the measure of angle 1 plus the measure of angle 3 is equal to. And instead of having the measure of angle PRQ, I'm going to replace that with the sum of its parts. And plug that right there is equal to the measure of angle 2 plus the measure of angle 4. Just setting these two equal to each other because we know that the holes, the big base angles are congruent to one another. Their measures are equal. What justifies the statement in green ink? Substitution. We're just plugging stuff in. Substitution. From there, we've now got 4 variables in one equation. This is different from this and this and this. However, we can replace either the measure of angle 3 or the measure of angle 4 for one of those. And so we can get one of the variables gone away because we know that the measure of angle 3 is equal to the measure of angle 4. So which one do you want to keep? 3 or 4? What? 4. Let's keep the 4. So we're going to keep the measure of angle 4. So we're going to replace the measure of angle 3 with what it equals to, which is the measure of angle 4. So we have the measure of angle 1 plus, we're going to replace this with what it equals, the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 4. What justifies this statement here in green ink? Substitution again. Just replacing some equivalent value in an equation. From there, what's on both sides of the equation? The measure of angle 4. So I'm going to subtract the measure of angle 4 from both sides. What justifies me subtracting the same exact value from both sides of the equation? It's the subtraction property of equality. And now I'm left with the measure of angle 1 equals the measure of angle 2. Now in the past, a lot of my students were confused about this, but what justifies this statement here? Subtraction property of equality. This is what justifies this statement because you always have to ask yourself, how did we get there? Or what did we do to be able to write this statement? That's what justifies it. And what we did to get here was that we subtracted the measure of angle 4 from both sides. Well, what allows us to subtract the same thing from both sides? Subtraction property of equality. So that's what justifies this statement here. If two angles have equal measures, then what else can we say about those two angles? And that they're congruent. What justifies the fact that angle 1 is congruent to angle 2 after that? What justifies this last statement? Definition of congruent angles. You will never write in a proof the definition of congruence. You will never, ever, ever, ever write that in a proof. Definition of congruence, don't use that. Do the definition of congruent angles with the definition of congruent segments. Questions about item 10 on this page. You are responsible for this proof. You will see this again. Can't be any more clear about that. Alright, so let's jump on over to the proof that was assigned for homework that was extremely similar to this one. That was on page 188. Please turn to that proof. So is extremely similar, and you go about it the same exact way. It's just the steps near the end are a little bit different. So it tells us that these two segments are congruent and also these two angles are congruent. We need to somehow show and explain that triangle ABC is isosceles. What is the definition of an isosceles triangle?
Two sides are congruent.
At least two sides are congruent. At least two sides are congruent. So if we're trying to prove that this triangle is isosceles, you need to prove it by the definition. You need to show that it truly is an isosceles triangle by the definition of isosceles triangle. So if that says that there's two congruent sides, we need to show that this triangle has at least two congruent sides. So let's look at what we're given, and then we'll try to get to that end goal. So it says that these two segments are congruent. It's already marked in your diagram, but you need to ask yourself, what are the implications of that? Well, if segment AB was congruent to segment BC, then we know that this is an isosceles triangle, making your base angles congruent of this large isosceles triangle. So this is starting off exactly like the other proof we just got done with. And if two angles are congruent, then their measures are equal. What justifies this second statement that I just got done writing? What justifies the second statement that I just got done writing? Definition of congruent angles. Definition of congruent angles is what justifies the second statement that I wrote. From there, it tells us that angle 2 is congruent to angle 4. So I'm going to mark that in my diagram. Now, unfortunately, there's really no large implications of that. Like, that doesn't show us that two segments are congruent. That doesn't show us that two other angles are congruent. That's just a piece of information that we need in order to prove and get to our end goal. But if two angles are congruent, then their measures are equal. So I can say that. I can make that transition from objects and congruence to measurements and equality. We'll jump over to that. And what justifies that transition from congruence to equality?
Definition of congruence.
Definition of congruent angles. All right. So, how are we going to show that this triangle has two congruent sides? All we're messing with right now is angles. How could we show that segment DA is congruent to segment DC? That's our end goal. That's what we need to do, show that that triangle is congruent. What would be the step before this, Grace? If we can somehow show that angle 1 is congruent to angle 3, then we can say that these two segments are congruent. What justifies that? Like, let's say we do all the work. Let's say that we do show that angle 1 is congruent to angle 3. And if that's the case, then these two segments are congruent. What justifies that statement? Well, I got a bunch of things. If angle 1 is congruent to angle 3, we're done with this. We've proved this. Not yet. We'll get there. Immediately after we get here, we're going to say that segment AD is congruent to segment DC. What justifies this after saying that? Okay, converse of the base angle theorem. That's the only thing that's different about this proof, is that we're going to be using the converse of the base angle theorem. Alright, so yes, that's what we need to do. We need to use angle addition postulate, the substitution property of equality, and the subtraction property of equality to get here. And then once we get here, converse of the base angle theorem. And if you were to read that, it says that if two angles of a triangle are congruent, then the sides opposite those angles are congruent, making that triangle isosceles. This is the converse of that theorem. So, here we go. So